In the vast expanse of our cosmos, a seemingly insignificant star twinkles quietly. It lies a mere 7.9 light-years away from us. This is Wolf 359, a celestial neighbor holding secrets yet unknown. Despite its proximity to Earth, Wolf 359 remains invisible to the naked eye. Its faint glow, a whisper in the cosmic ballet, hides a world of powerful stellar activity. Wolf 359 is a red dwarf star, smaller and cooler than our own sun. It is a celestial ember burning slowly through the cosmic ages. Though seemingly insignificant, Wolf 359 holds clues to the mysteries of star formation, stellar evolution, and the potential for life beyond our solar system. Its secrets beckon us to explore further. The study of Wolf 359 offers a glimpse into the future of our own solar system. As our sun ages, it too will eventually transition into a red dwarf star. Understanding Wolf 359 is crucial to understanding the ultimate fate of our own star and the planets that orbit it. The story of Wolf 359 begins in 1919, not in the depths of space, but in the mind of a German astronomer named Max Wolf. Wolf, a pioneer in astrophotography, developed a groundbreaking technique for detecting the movement of celestial objects. By comparing photographic plates taken at different times, he could identify stars that shifted slightly against the background of more distant stars. This technique, known as astrometry, allowed Wolf to uncover countless previously unknown stars, including the one that would bear his name. Wolf 359, as it came to be known, was initially just a blip on a photographic plate, a faint whisper of light from a distant corner of the galaxy. Its discovery marked a pivotal moment in our understanding of the cosmos. It revealed that our galaxy was teeming with faint, low-mass stars like Wolf 359. These stars, once thought to be rare, were actually incredibly common, outnumbering their brighter counterparts by far. Wolf 359 belongs to a class of stars known as red dwarfs. These stars are fascinating celestial objects that have intrigued astronomers for decades. These celestial objects are significantly smaller and cooler than our sun, emitting a faint reddish light that barely illuminates the cosmic tapestry. Their light is so dim that it often requires specialized equipment to detect them in the vastness of space. Red dwarfs are the most common type of star in the Milky Way galaxy, making up over 85% of the stellar population. This means that if you were to look at a random star in our galaxy, chances are it would be a red dwarf. Their sheer abundance makes them a subject of intense scientific interest. Researchers are keen to understand their properties, behaviors, and potential for hosting exoplanets. Despite their prevalence, red dwarfs are incredibly faint and difficult to observe. Their low luminosity means they often go unnoticed without the aid of powerful telescopes. Their low luminosity is a result of their slow rate of nuclear fusion. Unlike our sun, which burns through its hydrogen fuel relatively quickly, red dwarfs take their time. They burn hydrogen fuel at a much slower rate than our sun, extending their lifespan to trillions of years. This slow burn means that red dwarfs can outlive many other types of stars by a significant margin. This longevity makes them fascinating subjects for studying stellar evolution over cosmic timescales. Scientists can learn a great deal about the life cycles of stars by observing red dwarfs. Red dwarfs like Wolf 359 are much cooler than our sun, with surface temperatures less than half as hot. This cooler temperature affects not only their color, but also their potential habitability for planets orbiting them. This coolness results in a distinctly reddish hue, hence their name. The red color is a signature feature that helps astronomers identify these stars. Their faint glow and small size make them challenging targets for observation, requiring powerful telescopes and sensitive instruments to study in detail. Despite these challenges, the study of red dwarfs continues to provide valuable insights into the workings of our universe. Section 4. Stellar Tantrums. Unraveling the mystery of Wolf 359's flares. Despite its seemingly quiet demeanor, Wolf 359 harbors a fiery secret. This unassuming red dwarf star, located just 7.8 light-years away from Earth, is one of the closest stars to our solar system. Yet it is far from being a tranquil neighbor. It is a flare star, prone to sudden and intense bursts of energy that erupt from its surface. These flares can increase the star's brightness by several magnitudes in mere minutes, creating a spectacular, albeit brief, cosmic light show. These flares, though brief, release enormous amounts of energy, bathing any nearby planets in a torrent of radiation. The energy released during these events can be equivalent to millions of hydrogen bombs detonating simultaneously. The unpredictable nature of these flares makes Wolf 359 a fascinating, albeit potentially dangerous, celestial neighbor. For any hypothetical life forms on planets orbiting the star, these flares could pose significant challenges. The cause of these flares is still a subject of scientific debate. Researchers are keen to understand the underlying mechanisms that trigger such powerful outbursts. One theory suggests that they are caused by magnetic reconnection events in the star's atmosphere. This process involves the realignment of magnetic field lines, which releases a tremendous amount of energy. These events, similar to those that cause solar flares on our own sun, release vast amounts of energy in the form of light and radiation. Understanding these processes on Wolf 359 can provide insights into our own sun's behavior. The frequency and intensity of Wolf 359's flares make it a compelling target for astronomers studying stellar activity. By closely monitoring these flares, scientists can gather valuable data on the star's magnetic field and its interactions. By observing these flares, scientists hope to gain a better understanding of the processes that drive magnetic activity in stars, both large and small. This knowledge could have broader implications for our understanding of stellar evolution and behavior. These insights could shed light on the habitability of planets orbiting red dwarf stars. If we can understand how these flares affect planetary atmospheres, we might better assess the potential for life in these distant worlds. Section 5. A cosmic desert? The elusive planets of Wolf 359. The prospect of planets orbiting Wolf 359 is a tantalizing one, but it remains a mystery. This star, located just 7.8 light-years away from Earth, is one of the closest stars to our solar system. Despite its proximity, the search for planets around Wolf 359 has proven to be incredibly challenging. Despite extensive searches using various detection methods, astronomers have yet to find definitive evidence of planets around this enigmatic star. Techniques such as radial velocity measurements, transit photometry, and direct imaging have all been employed, but so far they have yielded no conclusive results. This lack of confirmed planets has sparked debate about the conditions required for planet formation around red dwarf stars. Some scientists argue that the environment around such stars might be too hostile for planets to form or survive. Some theories suggest that the intense flare activity of Wolf 359 could hinder planet formation. These flares, which are sudden eruptions of energy, can be powerful enough to disrupt the material in the protoplanetary disk, preventing it from coalescing into planets. The powerful radiation bursts could strip away the atmospheres of fledgling planets, making them inhospitable to life as we know it. This radiation can erode the atmospheres over time, leaving the planets barren and lifeless. However, other theories propose that planets could still exist in stable orbits around Wolf 359, potentially shielded from the worst of the star's flares by their magnetic fields, or by the star's own rotation. These magnetic fields could deflect the harmful radiation, allowing the planets to retain their atmospheres and possibly support life. The search for planets around Wolf 359 continues, fueled by advancements in observational techniques and a desire to understand the diversity of planetary systems in our galaxy. New instruments and methods are being developed to probe deeper and more accurately than ever before. The discovery of even a single planet around this nearby star would have profound implications for our understanding of planet formation, stellar evolution, and the potential for life beyond Earth. It would open up new avenues of research and possibly even change our perspective on our place in the universe.